So now we're going to match the types of functions. So the first one, periodic, a periodic function literally means that it has to be a function, right? So it passes the vertical line test. But periodic means that it returns to the same value at regular intervals, right? So sine and cosine waves or functions, those are classic periodic functions, right? Notice you have that oscillating. They return to the same value at regular intervals. So that is why the correct answer for number one, that is going to be H, right? So then for number two, we got a linear function that is going to be G, right? So remember H of X, the other way I could write it, that's the same thing as Y equals, right? They're all Y equals. But we call this one the H function. So H function. So that's Y equals 4. That is going to be a horizontal line, right? Crossing at the Y value 4. Quadratic, so that is where the degree or the highest exponent is 2. So that is going to be D, right? So the highest exponent is 2, so therefore that would be a parabola. A cubic function is where the highest exponent is going to be 3. So that's going to be part E, right? So here's that highest exponent there. A rational function, that's part B. That is pretty much just a polynomial over another polynomial, right? So remember, ratio is in the word rational. Now there's 3 different ways that you can write ratios. One of the ways is you can write them as a fraction, right? So it's, again, you could think of it as a polynomial over another polynomial. Number 6 is obviously easy. A logarithmic function would obviously have to have a log in it. Or I shouldn't laugh because maybe that's not obvious to some people. But anyway, so number 7, a piecewise function. So it's 2 pieces of different lines, or maybe one could be a line, one could be a parabola, right? So it's pieces of different functions together on the same graph. So that is going to be part A, right? So it's 2 functions on the same graph. We got a linear function up top with a specific domain, and we have a quadratic, a parabola on the bottom with a specific domain, right? So a piecewise function, it has to be a piece of it. So notice you're always going to have a comma, and then you're going to be given the domain of that function, right? Or else if it's all real numbers, it's not a piece anymore, right? Then it's the full line. So now number 8, an even function, that is going to be part C. So first of all, an even function is defined as graphically something that has is symmetrical over the y-axis. An odd function has symmetry about the origin. And that pretty much means if I take a piece of paper and look at a graph and I flip it upside down, that it actually looks exactly the same. That's what it means symmetrical about the origin. So that's the difference between an even and an odd function. But how are we supposed to know without graphing, right, that x to the 8th, that is an even function? So then we have algebraic definitions. So the even definition is if I were to substitute a negative x into the function and I simplify afterwards, if I get back the original function, that's the definition of even. So for example, right, so in part C, let's call, so that's the same thing as f of x, right, equals x to the 8th. So now what happens if I substitute negative x, right? So f of negative x, I'm just going to do that simple substitution, right? So either that means negative x times itself 8 times, or if you happen to know the shortcut, whenever you have something raised to an even power, it's always positive. Anything raised to an odd power, it's always negative, right? So, so that way we do get the original function, right? So negative x times itself 8 times, or you recognize it's to the even power, that does simplify to x to the 8th, which actually that is the original function, right? So that's why it's even. Odd, the difference with that is we're going to do the same idea. You're going to substitute the negative inside the function. And then when you simplify, what happens is if I go, if that negative comes out, right? So in other words, now the negative, so that's the same thing as negative f of x. That is the definition of the odd function. And as I said, graphically, it would look like it's symmetrical across the origin. So number 9, that is going to be J, okay? So if I substitute negative into the function, remember, if you have something raised to the odd power, then it's going to give me a negative, right? So I guess I'll just well, I'll continue it down here, right? So, or I can multiply negative x times itself 5 times, but regardless, we simplify it that way. And then remember that x to the 5th is f of x. So I just drop down the negative, and this I can make that substitution, right? So notice, yes, we have just proved that it's an odd function. And number 10 is super nice and easy. That is going to be letter F. Exponential function is where the x is in the exponent. I hope you found this video really helpful, and I want you to make sure that you check the description. I left links to also my online course if you're interested. I have chapter modules and quizzes and homeworks and step-by-step answer keys, and I have video lessons of those. So again, I left that link in the description. Make sure to like and subscribe, and make sure that you also leave a comment so that if you want to also request any future videos, I'd be more than happy to make those. So I hope to see you soon.